Good day, guys. Welcome to our another class on Calculus 2. Our topic for today will be definite integrals. Definite integrals, if the continuous of a function of x is a positive over the domain a less than or equal to x and x less than or equal to b, where a and b is your limits of your integral. Then the area under its graph will give you this process or this equation. So from here, you'll have to integrate your f of x. After that, you will substitute the limits from lower limit to your upper limit. Here, after you integrate it, you will substitute this one. And if you substitute this one, you substitute first the upper limit, then deducted with the lower limit of the value of the substituted lower limit. So in the definite integral f of x, so it is always implied that your a and b is the limiting values. Okay, so it means that you are getting the value within that limit. Okay, so if this is your if this is your a, this is your b, you are only getting those values, the value within those limit. So in the definite integral, we have three properties in definite integral. The first one, the second one, and the third one. The first one is the integral of a constant multiple of a function is the constant times the integral of the function. Meaning, the same as our second identity, that the value k, which is the constant, as I've told you, which is a value, constant value, is just move outside the integral sign. After that, you integrate it and substitute the limits, and lastly, you will multiply the constant. And the second property is the sum of two functions here, which is the identity number 3 that we've already discussed. So here, you need to just separate the two functions and then integrate individually, and you also do the limits individually. And the last one is one of the important thing you need to remember: if the sign of an integral changes when its limit of integration also interchange. Means, if you can see here, we all know that your lower limit is a and the upper limit is b. But in this case, your lower limit becomes b and your upper limit is a. In short, the upper limit is lesser value than the lower limit. Diba? What we always do is that the lower limit should be lower value than your upper limit. But in this case, the lower limit is higher than the upper limit. So what you need to do is to interchange those limit and then multiply with a negative value. So let's try to have an example here. So we have here, for example, of this one without the constant. So let's try to evaluate using this one. So evaluate cosine x with limits from 0 to pi over 2. Let's try. So from here, we know that the integral of cosine is sine. Positive or negative? That is positive because the derivative of cosine is negative sine. Therefore, the integral of cosine is positive sine. So here, the x don't have a constant, so therefore, we can integrate it directly. We have sine x with limits from 0 to pi over 2. Then, as I've told you, that when you substitute your limits, you should start with your upper limit. So you have sine pi over 2 minus the lower limit, sine 0. And we know that sine 0 is equivalent to 0. Okay? And sine pi over 2 is equivalent to 1. So therefore, the value or our answer is 1. So you use radian here. So because you are using pi, so Then also, uh, that's how you do it. You need to first substitute the upper limit, then deduct with the lower limit. Okay? So let's have another example, which we will discuss the first properties of integral. Okay? So let's have another example which tackles with the first property of integral. So I will erase this one so that we have space. Okay? This part. So if you could see, we deduct this one, we follow the rule. Okay? So let me erase this part. Okay. Let's have another example which explains the first property of integral. So let's say example, this is already example. It's just example. Integral of 8 e raised to the power of 2x dx. Limits from, we'll say, 1 to 2. Okay? Let's have limits from 1 to 2. So our given is 8e raised to the power of 2x dx with limits from 1 to 2. So we know here that we need to move the constant outside the integral sign. So, which is this one. We have constant here outside the integral sign 1 is to e raised to the power of 2x dx. And in this case, we'll just do the exponential functions, how to solve this one. But first, you need to derive your 2x. Your u is your 2x, your du is derivative of 2x is 2 dx, and we will get our dx, which is equivalent to du over 2. Then substitute that one to the given. So we'll have 8 integral 1 to 2 e raised to the power of u. And what is our dx? That is du over 2. So from there, you have 8 over 2 integral 1 to 2 du du. So from there, you have 4. Integrate. The integral of eu is still eu. So you have eu with limits from 1 to 2. But before we substitute the limits, we must remember that it is still u. So we need to substitute the value of u, which is 2x, limits from 1 to 2. Then we have 4 here. Just substitute e raised to the power 2, the upper limit first, minus e raised to the power 2, the lower limit. Then we'll have 4 times e raised to the power 4 minus e raised to the power of 2, right? And if you use your calculator here, this value will give you 188.836. Okay? So, you would also get this one using your calculator because it is much easier. You just look for the integral sign, click that one, and then write these values. If you are wondering where will you get those x, the dx is already given there. So if you are looking for the variable x, then you put alpha, then look for the variable x. Click alpha, then press the variable x. Okay. So let's have more example. Okay. So let's try another example. So let me erase this part because we're done with the first property of definite integral. Let me erase this one. Okay. So another example is, let's say we have integral 2x plus 1 dx, limits from 1 to 2. Okay, so we have this given, sorry, that is dx. So in this given, it is an example of the second property of integration, which of the definite integral. So which is the sum of the function is the sum of their integral. So the sum of this function is the sum of the integral, which we need to separate. So we'll have first integral 2x dx limits from 1 to 2 plus integral dx, because 1 times dx till dx limits from 1 to 2. So you have to move the constant outside the integral side, plus dx 1, 2. So the first one is, the first function is using power rule. So you have 2 multiplied by, x squared, because that is plus 1 over 2, limits from 1 to 2, of 1 to 2, plus x limits from 1 to 2. So therefore, we can cancel this one. What remains is x squared limits from 1 to 2 plus x limits from 1 to 2. So we have here, substitute first the upper limit. We have 2 squared minus 1 squared for this first function. You have next, for the other one, you have 2 for the upper limit minus 1. So therefore, you have 4 minus 1 plus 2 minus 1, which is 1. So therefore, you have 3 plus 1, or the value we are looking for is 4. What is important here, because we get the exact value, this is very important, especially when you are solving application ng mga problems. Okay? So let's try more example. So especially here, this is most common. So let me erase this one to have space for the next example. Okay. So our next example is 4 minus 8 over x squared dx with our limits from still 1 to 2. Let's try that one. Okay? Let's try that one. So from here, we need to separate it as the sum of two functions here. So separate that one. So you'll have integral 4 dx with limits from 1 to 2 minus integral 8 over x squared dx limits from 1 to 2. Move outside the constant. You have 1 raised to, you have dx with limits from 1 to 2 minus 8 dx over x squared limits from 1 to 2. From there, because if you use logarithmic here or ln, we need to use this one as RU. When you use this one as RU, the derivative of this, that is 2x dx. In here, in our numerator, we don't have the value of x. So therefore, we cannot use the ln. So what we'll use is the power rule. We'll just transpose this one in the numerator and the sign will be changed. 1 to 2, then dx minus 8 x raised to the power negative 2 dx. Now we could integrate this one. So you have integral of this, integral of dx is x, 4x limits from 1 to 2 minus 8x, diba? Power negative 2 plus 1 over negative 2 plus 1, right? With limits from 1 to 2. So you have 4x limits from 1 to 2 minus 8x negative 1 over negative 1. So we have negative 1 there. So from there, let's continue. We have 4x 1 to 2 negative times negative 8 times negative 1, that is positive 8 x raised to the power of negative 1. Limits from 1 to 2. So 4x, and we could write this one to make it more easier. Limits from 1 to 2 plus 8, 1 over x, limits from 1 to 2, right? Because 1 over x, when you transpose, that is still x raised to the power of negative 1. So you have 4 times, substitute the upper limit, 2 minus 1, minus 8 times 1 over 2 minus 1 over 1, right? Or that is equal to 1. So you have 4 times 2, 4 times 1 already, minus 8 times, that is negative 1/2, right? So, okay, that is positive, that is positive, because that is negative, that's positive. Okay, so therefore you have 1/2 minus 1, or 1/2 minus 1, you'll have 4 plus 8 times, that is negative 1/2. Alright? So therefore, you have 4 minus negative 1/2. 8 divided by 2, that is 4. 4 minus 4, you will have 0. Okay? So therefore, you have 0. Okay? So in this case, actually, my given problem is positive. So this should be 8. So, but we already do the negative one, so let's continue. Okay, so it will result with 0. Okay. Next, let me erase this one so that we'll have value for our, or example for our next problem, or next properties, which is the third property, which is the interchanging of the limits. So let's say another example, which is integral 5, say, minus 6x squared dx. Limits from 1 to 0. Okay, so from here, we have this, which is, we know that our upper limit is lower than our lower limit. The value, the upper limit should be higher than the lower limit. But in this case, the lower limit is 1 and the upper limit is 0. So what we need to do is to interchange those limits. 0 becomes here, puts here, and 1 is on the upper limit. Then write 5 minus, write the function, then multiply it by negative. Okay, so after that, you separate the functions. You have negative for everyone, 5, you have integral from 0 to 1, 5 dx, minus integral 6x squared dx from 0 to 1. So integrate it individually. Negative 5x limits from 0 to 1 minus 6x cubed over 3 limits from 0 to 1. And we can continue here, minus Negative 5x limits from 0 to 1 minus that is 2, right? 2x cubed limits from 0 to 1. So we will have to substitute it. Negative 5 times 5 times 1 minus 5 times 0. For the another function, you have 2 times, you have 1 cube minus, okay, so we can have it para it will be easier. 5 times 1 minus 0. Well, let's write it like that. Okay. Then we have then 0 cube. So from there, we'll have false negative. That is 5. That is 1. 2 times 1, right? So we'll have negative 5 minus 2. And you have negative, that is 3. Therefore, you have negative 3. Okay? So that is for our third properties of definite integral. And all of this is very important, especially when you're solving application problem. Especially on differential equations. And mga problems like areas, volume, and etc. Centroids. So I think that will be all for our session for today. And see you on the next topic. We are already done with the integration concept and formulas. So next meeting or next section, we will be discussing about the integration techniques. So there are many techniques in solving integration that cannot be solved by the mere formula that is given by the integration formulas. Okay? So, example, integration by parts, the rational fractions, the trigonometric substitution, and many more. Okay? So, see you next session and good day.